So let's start from the definition of geoprocessing. It's very simply put an operation within GIS or using certain procedure within GIS to manipulate spatial data. We perform this manipulation either on one or more spatial data sets. What's important is that the result of geoprocessing is a new data set, a new permanent data set. So geo, because we are using or we are performing or manipulating spatial data, and processing because we process spatial data. So the definition is not really very complicated. There's a lot of geoprocessing operations. If you recall from recordings from previous week, where I was showing different components of GIS, there was one pane where you had a lot of tools, and many of those tools are actually part of spatial analysis and geoprocessing in particular. In this class, we are going to focus just on a few, those that are most commonly used or those that are critical to really understand spatial analysis. First, we're going to start from very simple operations, buffer, clip, and dissolve. Then I'm going to move on to map overlay, a concept that sometimes confuses students, so listen to it carefully. I will mention conversion between vector and raster data. Then I'm going to talk about map algebra, but don't get scared. It's not the same level of algebra as in high school or in college. The name is very, very serious when you actually analyze what the types of operations that you're doing. What's important is to mention that those first operations actually are being performed on vector data. For raster data, we have different set of operations, and that's under the whole term map algebra. And finally, I'm going to show you one particular model, because if you really get into spatial analysis, eventually you end up with modeling, where modeling can be just a combination of multiple operations that are going to be performed in a sequence, or it can be something that emulates reality. For example, a model that tries to simulate residential development over time. And the model that I'm going to talk about is very simple. Therefore, that's why I am introducing it in this class. It's called multi-criteria evaluation, and specifically spatial multi-criteria evaluation, because we are going to deal with spatial data sets. A hint here, this particular modeling is the topic of the extra credit quiz. So let's start with those very simple operations. Let's actually start from the simplest one, which is buffer. Buffer is simply a zone within a specific distance around a feature. As I mentioned before, we deal with vector data here, so you can create buffer around lines, points, and polygons. To create a buffer, you have to specify the distance. So when you use a tool that performs buffering, you have to tell GIS what distance you need for that to delineate that zone. Why do we use buffers? Well, buffers usually allow us to represent certain features or phenomena that are close to a focal feature like a river, a road, a point, let's say a point of noise, or some polygon, for example, school, right, or the area of school. So, for example, within when you have a stream or a river, there is a certain neighboring zone with specific type of habitat. It's called riparian zone, and buffers are actually a perfect way to represent that in GIS. For roads, for example, you can create a buffer within which you have a certain level of air pollution or certain level of noise. You can have a buffer around an oil spill, right? I talked about oil spill in the context of distance decay. You can specify within what distance you're going to have severe contamination that may be harmful to humans. And then you can create a buffer around a lake, for example, to delineate zone where people can rest or essentially delineate recreational area where you use both the lake but also the beach around that lake to rest or to do some physical activity. Here you have another example of a buffer. The background is a satellite image with a location of a school. And here you have a highlighted area that's park or greenery. And you have two buffers actually created here. One is within a quarter of a mile from school, and then another is within half a mile from school. So what you could do with this buffers is you could evaluate the patches of land that are available to students within walking distance. So in general, that would be showing or mapping green spaces near a school. Another simple spatial analysis operation or geoprocessing operation is CLIP. So just to reiterate, when you do buffering, when you apply the buffer tool, you generate new data set, right? Those polygons are new data sets, right? It's not something that's just displayed on a map. It's a data set that's being saved. You can then reload it for further analysis or mapping. So the second simple operation, simple in the sense that it's pretty common and doesn't require much of a thinking, is CLIP. CLIP is cookie cutter to select features from other features. A simple example would be cities in the United States, and then you'd like to select only cities that are in California. So that California, the outline of California would be your cookie cutter, and you would then cut only cities that fall within the region or the polygon that outlines California, and all the other cities would not be present in the output. So in the output, you would only have points or polygons representing cities in California, and the rest of the United States would be discarded. And here you have an example. Oh, by the way, unlike buffering, where you have only one data set and you create a new data set from one data set, for clip, you need to have two data sets. You have to have the data set that you want to clip, and then you have to have the data set that shows or delineates the region within which you want to have the output, and which is going to show sort of the cookie cutter piece, right? So this is, if we were talking about the example of cities in the United States, the input would be the cities in the United States. The clip feature would be the polygon that represents California. And then as a result of clip, you would have cities only within California. So everything outside of the clip feature would be discarded. Another example, so clipping is not just about points. Obviously, you can clip polygons, you can clip lines. So here you have streets as your input layer, and then you have a clip layer. This is this polygon, in yellow polygon, which delineates central business district. And after applying clip, the output layer would be streets only within the central business district, which is this area here. And dissolve is another simple operation, and dissolve allows you to generalize a data set based on specific attribute. So in dissolve, again, just like in buffer, we only deal with one data set. Unlike clip, where you have two data sets, input data set and the clip data set, in dissolve, we deal with one data set. So dissolve is simply aggregation of items that have the same value. So dissolve relies on attribute table, right? So for dissolve, we use the attribute table, feature attribute table, where there's a certain column which we use to generalize the region, generalize items. So schematically, if you had multiple tiny polygons that have specific value of some variable, you could use dissolve to combine them together based on that value. So here you have, for example, green polygons. That would be polygons with value green. After dissolve, you would have one big polygon with value green. And I have example, kind of a more real world example here. That's the same data as I used in queries. So you have the region of San Diego with zip codes, and what you want is instead of having zip codes, you only want to have communities. So right here you have zip codes, but there is one attribute in the attribute table that says community. And if you look into that, you can see that there are only two communities, San Diego and La Jolla. So if you use the dissolve tool, this is what you're going to, this is your target, right? This is what you want to obtain. You want to have one big polygon without those lines that represents boundaries between zip codes. You want to have one big polygon for San Diego and another polygon for La Jolla. This is the dissolve tool. As I said before, for dissolve, you have to have an attribute that you use to aggregate your features. So this is zip codes. I'm going to create a new data set, obviously, and I highlight community right here as my attribute for dissolve. And that's the result. So as a result, as I said, you don't have the zip codes anymore. You just have two polygons with communities, La Jolla and San Diego.